So hello everyone, my name is Priyanshu Chaniyara and my team name is localhost 5173. So the problem statement we have selected is a green hydrogen infrastructure mapping and optimization. So let me move you towards directly to the solution project we have made. So alright, so this is a solution project we have made for this problem statement. So our project name is GreenInfra. So let me first go through the home page. So this is the home page. I have already logged in to this site, so it shows me the demo user, and uh, here I have mentioned the four reasons that why to choose a green infra and trusted by industry leaders. So basically, we haven't become a large scale yet, so this is a dummy data right now. Okay, so that was about the home page. Now let me move you towards the functionalities that we have made. So this is a dashboard. So dashboard includes the basically of a infrastructure map optimization and analytics, which I have mentioned in the navbar. So dashboard includes all the information, right? Overview of the all the things. So let me show you first the functionality, then we'll go on the dashboard section. So first let's see the infrastructure map. So infrastructure green hydrogen infrastructure mapping basically shows that where are the plants in the maps. It shows basically the location, and these dots like W H D D color wise we have bifurcate them. You can show right here the green for production plants, blue for storage facilities. This pipeline symbol is for pipelining networks, yellow is the renewable sources, red is for demand centers, and square is for regulatory zones. So okay, and also we have as it's a dynamic data, we have also inputted all we have also included uh, some of the production plants, and there is also functionality that we can show it via different type of mapping, like it is a satellite mapping, so we can also show the view in the satellite mode. All right, and okay, so that's how I talked about what is this, and I have to include that add the infrastructure. Let me show you the add the infrastructure functionalities. So by clicking on the add the infrastructure, we have to first select that where we want to put the infrastructure project. So as I click here, I want to put it here. I just click here, then I have to select the infrastructure type, whether it is a hydrogen production plant, storage facility, pipeline network, or renewable energy source. It's mentioned in the problem statement, then we have to solve these three kind of things. So suppose I have selected the storage facility and I have named it as an example storage, and we have to enter the capacity in megawatts. I am entering 500 megawatt capacity, and what is the status? Like our problem, our solution is focused on not just the existing projects. If it is under construction, it is planned, it is maintenance, or it is active, we can easily predict that what kind of circumstances or on what kind of circumstances it gives us the results. So I am selecting the active status, estimated costs in million USD. We have put the dollar because we want to like we want a currency that everyone can use, and like there are also tools available to convert the any currency into dollars. So basically one currency. Estimated cost, let's suppose 10 million, and description okay. So also the location what I've selected, it shows me the latitude and longitude right here, and by putting that infrastructure is added successfully. Now uh, by quick actions we can show the view projects, and right now the projects are there. We can show Pacific Coast Hydrogen Hub and an industrial district expansion. We can show the progress by the percentage we have given. By clicking on the infrastructure overview, we can see that how many production plants are active, there storage facilities, renewable resources, and demand centers. And from the predictive analytics, we can show that what are the tons next year of, like what are the demanded tons next year of a production of a H2, and what are the efficiency gains and what are the cost reductions. So they are basically implemented by the Python libraries and all the logics. And here it comes to a cost analytics. So it is also calculated by the data we have get from the users. It means the existing data we have on our site and the environmental impacts. So it's the same as the cost analytics. We have calculated all the things and displayed here. What is the CO2 impact? What are the water usage and what are the land uses? So now let's move on to the optimization. So as it is mentioned in the optimization, uh, it is mentioned in the problem statement. Let me show you how this optimization works. There are a certain parameters on base of the optimization works. So first is a budget. Like if I am making a plant, then first I have to decide the optimize. I have to decide the budget. So here is the budget criteria. I have to select here with the budget. Uh, we have searched the data from online, and we have get to know that most of the infrastructure projects are ranking from the $100 million to $1,000 million. So let me select any random value. And so if my budget okay, let's suppose if my budget is a $305 million and time frame of years is, let's suppose, 10 years. And optimization priorities, like what is the priority of optimization? Cost, efficiency, environmental impact, or rapid development. If I select environmental impact and the targeted region I have selected, uh, uh, the uh, the reason we have put this for region is that most of the infrastructure right now is established here, as we have made the research. So if I select Asia Pacific, and then what is demand scenario, uh, the reason we have put the drop down right here, it's because we have get all the data and we have averaged them, and we have put directly that the user can directly select here and get the optimization results. So if I select the moderate and we run the optimization, right? Okay, so optimization is run. So here the configuration one, which we have selected, and let's show the result. The optimization results are five new plants, three new pipelining, one storage facilities, and 22% cost saving. And the recommend, as we have added the plants in the infrastructure map. Based on that, it will recommend us the infrastructure, that what would be the best for it. So in a location is Australia, capacity is 9.3 megawatt, which would be the best for a low environmental impact and storage facility. Uh, Also another one storage facility, South Korea, and another is Japan. Okay, so that will basically show the results. And let's move towards the analytics. So let me once refreshes. Okay. So as per we added the optimization, the data directly came to the analytics page. So based on the data we have added, the total capacity would be 23.5 megawatt, monthly production, average efficiency, storage utilization. And this chart shows basically the hydrogen demand forecast is that by the uh, by the further years, how the hydrogen demand in metric tons would be increased. And this chart shows basically production capability by type: solar, wind, offshore, or hydrotric. Okay, so it is a monthly production trend, storage facility utilization, infrastructure summary. uh, by this data, we can basically get faster analytics. We don't have to go to the another tools for analytics. We don't have to use the Power BI for this, and we can add another feature for the, like if we go to the dashboard, we can easily export the data. Like if a user want a very detailed analytics, if it want a user want to go to the AI or wants to go to the Power BI like tools, a user can export the data. Okay, so here you can see the data would be exported in a JSON format, and user can easily integrate that data. That means user can easily use that data for analytics. Okay, and these are basically quick action that would move me directly to the infrastructure map, optimization, and analytics. So that was the all project solution we have made. And also add on thing that we have successfully made this project and we have deployed it on the Vercel, temporary on the Vercel. So it is working correctly. So that was all about our project. Thank you.